colligative properties. We have read what are the colligative properties, the properties which depend upon the number of the solute particles. Number second, we have also determined the molecular mass on the basis of colligative properties. We have determined these molecular mass in case of elevation in boiling point and depression in freezing point, and it has been found that molecular mass or molar mass obtained by these methods, obtained obtained by measuring the colligative properties. Molecular mass obtained by these methods do not agree with the theoretical or theoretical value. Molecular mass obtained on the basis of by these methods, we have read the colligative property, elevation in boiling point and depression in the freezing point, and in that we have calculated the molecular mass. But it has been found by molecular mass obtained by these methods do not agree with the theoretical or expected value. The accurate molecular mass can be obtained if the solution satisfies the following conditions. Number one, the solution must be dilute. In case of concentrated solution, if we take the concentrated solution, there occurs interaction between the solute molecules, and there occurs interaction in solute and solvent interaction also takes place. As a result, colligative properties change. So the molecular mass also show the abnormal value. When the molecular mass, when the accurate molecular mass, the molecule which is expected or the accurate does not agree the molecular mass obtained on the basis of colligative property, that molecular mass is called the abnormal molecular mass. Now I have told you that the molecular mass can be obtained, accurate molecular mass can be obtained when the solution is dilute. If there is concentrated solution, there occurs interaction between solute molecules as well as solute solvent molecules. As a result, colligative property change. Since colligative property depend upon this number of solute particles, so the colligative property change, and so the molecular mass obtained is abnormal. Second reason, in case of if there occurs association or dissociation, there occurs association or dissociation. That means if the solute particles interact, they can associate or dissociate. So colligative property, that is number of the particles increase or decrease. In case there occurs association or dissociation, number of particles increase or decrease, colligative property changes, so the molecular mass changes. That means this, in case the solution must not associate or dissociate, if there is any association or dissociation, the number of particles increase or it may decrease, and the colligative properties may change, which cause change in the molecular mass, so the molecular mass obtained is abnormal. Now I will take first association of the solute particles. Dear students, in case of non-polar solvents, solute particles associate to form a bigger molecule, and so number of particles that you add in the solution decrease. For example, if we take benzene as solvent, in benzene both ethanoic acid as well as benzoic acid undergo association. They form dimers. For example, in case of ethanoic acid, two ethanoic acid molecules, they combine as a result of hydrogen bonding. Hydrogen bonding takes place and dimers are formed. Since molecular mass of ethanoic acid, one molecule is 60, but here the two molecules associate, dimer is formed, so molecular mass obtained is 120, because two molecules associate form a single molecule, and molecular mass obtained is, since colligative property is directly proportional to number of particles, and number of colligative property is inversely proportional to the molecular mass. Colligative property is inversely proportional to the molecular mass. Since the colligative property decreases, because colligative property is directly proportional to the, that is equal to number of particles. So the number of particles decrease, so colligative property shows a lower value, but colligative property is inversely proportional to the molar mass, so molar mass shows a higher value. That is why in case of benzene as a solvent, when we determine the molecular mass of ethanoic acid and benzoic acid on the basis of colligative property, that comes to be 120 in case of ethanoic acid and 244 in case of benzoic acid, because there takes place hydrogen bonding. For example, benzoic acid, here hydrogen bonding takes place, so dimers are formed. So in case of association, when the molecules associate, this happens usually in the non-polar solvents, as in benzene. The two or more molecules may associate to form a bigger one, as the number of particles or the number of particles added, they decrease. So the colligative property shows a lower value. But colligative property is inversely proportional to the molecular mass, so molecular mass shows a higher value. That's why in case of ethanoic acid, in case of benzene taken as a solvent, ethanoic acid and benzoic acid shows the higher molecular mass. In case of ethanoic acid, it comes to be 120, double than the normal. And in case of benzoic acid, it comes to 220, 244, double than the normal. This molecular mass obtained is known as abnormal molecular mass. Now, in case of association, now if this was in case of association, where the colligative property shows a lower value and molecular mass increases. If we take dissociation into consideration, In case of dissociation, in case of in case of some electrolytes, for example acids and some in bases, molecules dissociate. For example, AB, it gives A positive, B negative. For example, when we add, for example, NaCl, or we add potassium chloride in water, it ionizes. For example, if we take potassium chloride in water, it ionizes, it gives K positive plus chloride negative. That is, if we add 1 mole of KCl, we will get 1 mole of potassium ions and 1 mole of chloride ions. That is total number of, there are 2 moles. 1 mole of potassium chloride gives 2 moles of potassium, 1 mole of chloride ions, 1 mole of chloride ions. That is total 2 moles. So colligative property increases. Colligative property depends upon number of particles. As in case of dissociation, number of particles increases. So colligative property shows a higher value, and molecular mass obtained is lower than the normal, because colligative property is inversely proportional to molar mass. Since colligative property shows a higher value, molecular mass obtained by this method will be lower than the normal. For example, if we take 1 mole of KCl and in 1 mole of, if we take 1 mole of KCl in 1 kilogram of water, we will expect the elevation in boiling point. That is, there are 2 moles formed, that's 2 into 0.5 to 52 Kelvin. That is elevation, but elevation that which takes place in the water is expect 1.44. It's 1.04 Kelvin elevation takes place. Colligative property in case of dissociation, as we in case of some acids and bases, when they are added to water, they ionize. As they ionize, number of particles increase. So colligative property shows a higher value. Since colligative property is inversely proportional to molar mass shows a lower value. For example, in case of KCl, KCl gives K positive plus Cl negative. That is, number of particles increase, becomes double. So the molecular mass will be half than the normal. This is the abnormal molecular mass. In 1986, in 1886, a scientist that was known as Van 't Hoff introduced a factor called Van 't Hoff factor to express the extent of association or dissociation. To express extent of association or dissociation, Van 't Hoff factor is defined as, it is denoted by, designated by I. It is defined as ratio of normal molar mass to the observed molar mass. That is, I is equal to normal molar mass divided by observed molar mass. Since molar mass is inversely proportional to the colligative property, therefore I is equal to observed value of colligative property divided by normal value of colligative property. And you have seen this molecule associate and they will also dissociate. If you must keep in mind, if association takes place, molecular mass, as in you have read ethanoic acid and benzoic acid, molar mass is more than the normal. You have seen, I will show again, in acetic acid dimer is formed. Or benzoic acid. So in case association takes place, molar mass becomes more than the normal. Monomer factor I is less than 1. This comes in the examination as a multiple choice question. In case of association takes place, monomer factor is less than 1 because mole mass is more than the normal. So monomer factor I is less than 1. Number second case, in case of dissociation, molar mass obtained is less than the normal. So monomer factor I is greater than 1. In case of dissociation, monomer factor is more than 1, that is greater than 1, because observed molecular mass is less than the normal. In case the neither association or nor dissociation takes place, therefore observed molar mass will be equal to the normal, that is monomer factor I is equal to 1. Monomer factor I will be equal to 1. So you must keep in mind, in case of association, mole mass obtained on the base of colligative property is more than the normal. Monomer factor I is less than 1. In case of dissociation, mole mass obtained on the base of colligative property is less than the normal. I is greater than 1. And in case there is neither association nor dissociation, then observed molecular mass is equal to the normal value of molar mass. So I is equal to 1. This was the abnormal molar mass and the